Hello friends and my dear students, I welcome you all to my channel. I hope you're all well and your studies are also going on well. So this is problem set 10 good problems set number 1 on the chapter of squares and square roots, which I have just completed in the playlist CBSC Maths 8 RS Agarwal. So if you have not watched, if you want to have a good understanding of the chapter of the concepts of squares and square roots, then you can watch all my theoretical videos from the playlist CBSC Maths 8 RS Agarwal. And this is set 1 uh, of 10 good problems. So this video is a part of the series of videos which are 10 good problems based on HOT. HOT means high order thinking problems. So once you have completed a chapter, then to evaluate your understanding of the concepts of the chapter concepts, you can practice these problems and solve these problems, and you will get a good evaluation of your understanding. So this video is part of the playlist CBSC Maths 8 HOT. HOT stands for High Order Thinking, where I will come up with 10 good problems every now and then for each chapter as and when I will complete those chapter in the playlist CBSC Maths 8 RS Agarwal. So this is the first set on the first set of 10 good problems on the chapter of squares and square roots. It is highly recommended that you first try to solve these problems yourself. Only after multiple attempts, if you cannot solve it, then you can see my solution video. And also, please solve these problems once you have completed your study on the relevant chapter and have solved quite a bit of problems from your textbook or any other reference book. Okay. So if you are new to my channel or not yet subscribed, and if you are watching my videos regularly and my videos are beneficial to you, then I strongly suggest and request that you support me by subscribing to my channel. And also please do not forget to press the bell icon so that you will be notified by my future videos. So let's start solving 10 good problems for the set 1 on the chapter of squares and square roots. Okay, so I have the set of 10 problems on the left hand side on the chapter of squares and square roots. And on the right hand side, I will solve the problem. Let me quickly check if everything is visible or not. I hope you can see the question paper properly, and it is the fonts are large enough so that it can be read properly. Okay. So while solving the problem, after solving a problem, I will pause for a few seconds so that you can take a screenshot of the solution if you think the solution will help you and you as a future reference. Okay, so let's start solving the problems. Problem number 1 says, for a prime number m, let a be the number. A is given to be 2 to the power 2 square multiplied by 3 cube multiplied by 4 to the power 4 multiplied by 5 to the power 5 multiplied by m to the power m plus 2. M is a prime number. Let a be the number this. Then the least number to be multiplied with a to give a perfect square number is. Okay. So basically, this is a problem. The pattern of the problem is that you are given a number. We have solved this kind of problem. We are given a number, a specific number, and we are asked to find the least number that should be multiplied with that number to make it a perfect square. Okay. So instead of giving the number, it has been given in terms of the powers of prime factors, I guess. Okay. So what is a? Let's see what is a. So a is 2 square multiplied by 3 cube multiplied by 4 to the power 4 multiplied by 5 to the power 5 multiplied by m to the power m plus 2. Now the idea was that we have to create, this is m is a prime number. Okay, so m is a prime number, and we can also see 2, 3, 2, 3, 5 is a prime number, but 4 is not a prime number. Anyway, now the idea was that for a given number, we do the prime factorization and we try to pair all equal factors. We try to create pairs of equal factors, and whatever the factors are left behind, which is not part of any pair, product of those numbers is the required least number that need to be multiplied to make it a perfect square. Okay, so let's try to see rearrange these given factors. Now 2 square is fine. 4 to the power 4, we can write it as, let's bring it with the 2. 4 to the power 4, we can write it as 2 square, and that whole raised to the power 4. And then we have 3 to the power 3 and 5 to the power 5, and we have m to the power m plus 2. Okay, now this is, if we merge, no, we cannot merge. Okay, so we have 2 square multiplied by this will be 2 to the power 8, because 2 square and whole raised to the power 4 becomes, we know that x to the power m, and then this whole raised to the power n is equal to x to the power m into n. Applying this concept, we can say that 2 square raised to the power 4 is 2 to the power 4 into 2, that is 2 to the power 8. And we have 3 cube, 5 cube, 5 to the power 5, and m to the power m plus 2. The idea is to figure out which are the factors which cannot be considered as a part of any pair. Now 2 square multiplied by 2 to the power 8 becomes 2 to the power 10. The powers get added, and we have 3 to the power 3, and we have 5 to the power 5, and we have m to the power m plus 2. Now remember that, okay, so this is equal to, we can 2 to the power 10, we can write it as 2 to the power 5 square, and we have 3 cube, we can write it as 3 cube, we can write it as 3 into 3 multiplied by 3, and the 5 to the power 5 we can write it as 5 to the power 4 multiplied by 5, and we have m to the power m plus 2. It is just that you have to manipulate the powers and create factors such that you can easily understand which are the factors which cannot be part of any pair. Now 2 to the power 5 whole square, that is already a square of some numbers. So anything square, any power, any exponential term where the power is an even number, like twice m, x to the power, but x is a non-zero rational number, x to the power twice m, this exponential this means x multiplied by x 2m times, and 2m is even number, so we can always create pairs of equal factors from this number x to the power twice m, and there will be m pairs, m such pairs, and equal factors are x. So any power, any even power will always be considered, can be expressed as a pair of equal factors. Now, okay, so this is from okay, now we have 3 into 3, this is already a pair. Now we have 1 3 left behind. Now 5 to the power 4, we can say it as 5 square to the power square, and we have 5, this 5 will be left behind, and we have to see what about m to the power m plus 2. Now see, if you ignore the m to the power m plus 2, the other factors, only the 3, 1 3 and 1 5 is left behind, which is not part of any pair. Every other factors are part of pairs. This thing is a pair because it is a power of even. It is a 2 to the power that is a 2 to the power 5, that is a number. The main it is a square of some number, so it can always be considered as a pair of equal factors. That is, an equal factor is 2 to the power 5. 3 into 3, this is a pair. 5 square to the power square, so this is also a pair, that is where the equal factors is 5 square. Now 5 is left behind, 3 is left behind. Now we have to see what is m to the power m plus 2. Now see, m is a prime number. M is prime. M is prime, and prime is always odd. This implies an odd number. This implies m is odd. This implies if m is odd, then m plus 2 will be odd. M plus 2 will be odd. You consider if m is an odd number, let's say 1, if you add 2, it becomes 3. You take any odd number, 7, you add 2, it becomes odd number. So any odd number, if you add 2, then the result also becomes an odd number. So m plus 2 is an odd. So the power is odd. So you cannot, so m to the power m plus 2 is not, you cannot create a pair of factors. You cannot create, is not forming, is not perfectly forming pairs of factors. So you have to multiply to make it so. So m, since m is a prime number, now m plus 2 is an odd number. So this implies if we multiply, since m plus 2 is an odd number, if I multiply this m to the power m plus 2 with 1m, this whole thing will form pairs of equal factors. Why? Because equal factors. Why? Because m plus 2 is an odd number. If m plus 2 is an odd number, and if I add 1 to it, that is now why m to the power m plus 2 multiplied by m is will form a pair of will form pairs of equal factors. With equal factors, you will be m, because m plus 2, the power m plus 2 is odd number, so it is not forming pairs of equal factors. One factor will be left behind, that is m. So if I multiply another m, so the factor that m is left behind, with that it will form another pair. So it has to be multiplied. M to the power m plus 2 when multiplied by m will create pairs of equal factors. So the underlying, so what this implies least number to be multiplied with a to make it a perfect square, is 3 multiplied by 5 multiplied by m, which is equal to 15 m. So 15 m is the least number that need to be multiplied with a, which will make it a perfect square. So the answer is choice D. Answer is choice D. So you can take a screenshot of the solution. Let's do problem number 2. Let's do problem number 2. It is saying if 1 plus 3 plus 5 plus 7 plus up to n odd integers is n square. So we know this fact. We know this is as a property of square numbers, that the sum of first n odd integers, that is odd positive integers, like 1 plus 3 plus 5 plus 7 plus 9, like this, the first n odd positive integers, sum of first n positive integers is n square. We know this. Now it is asking to find then the value of 23 plus 25 plus 27 plus up to 89 is. Okay, so we have to find the sum of 23 plus 25 plus 27 plus up to 89. Okay. Now we know the sum of 1 plus 3 plus 5 plus 7. We know that the starting from the first odd positive number, the sum of all consecutive odd positive numbers, that is 1 plus 3 plus 5 plus 7, like this up to n terms, up to first n positive integers is n square. Now how do we find 23 plus 25 plus 27? Even though we can see that all these numbers are odd positive integers. 23 is odd, 25 is odd, 27 is odd, 89 is odd. Now see, you will realize that all these numbers is basically, if you from 23, if you consider, if you write 23 as 1 plus, it is 1 plus 22. Similarly, the 25 will be 3 plus 22. 3 plus 22. It is like that. It is like that 22 has been added with all the first all the consecutive odd positive integers. So 25 is 3 plus 22. 27 is 5 plus 22. This way we will have 89 will be 67 plus 22. 67 plus 22. Okay. Now if you can see that 22 has been added, we can express all these odd numbers as some number as the consecutive odd numbers plus 22. 22 is added with all these numbers. So if I separate out all the 22s, I will get, and if I combine the 1 plus 3 plus 5 like this up to, we will get 67, and I will get how many 22s? I will get 22 plus 22 plus like this 22. Now we have to see. Now we have to sign. So we notice that the number of 22 terms in this expression will be equal to the number of odd integers in the first expression. So in the first bracket, inside the first bracket, we are having the sum of consecutive odd integers like 1 plus 3 plus 5 plus 7 up to 67. Now let's say, now we have to first, now these 1 plus 3 plus 5 up to 67, if there are n number of terms, then there will also be n number of 22s inside the second bracket. So we can clearly see that the first bracket, inside the first bracket, let's say this is 1 plus 3 plus 5 plus up to 67. Let this be sum of, let's say we have to find n, that is the sum of, we have to find n, that is 67 is so we know that the first odd integer is 1, the second odd integer is 3, the third odd integer is 5. Similarly, we have to find which as per serial number, what is the n, which odd number, what is the sequence number of the odd integer 67. Like for 5 it is the third odd integer, 3 it is the second odd integer. Similarly, we have to find 67 which nth odd integer it is. So we know that the inside the first bracket, this sum is sum of, let's say sum of first n, we have to find n odd integers, that is odd positive integers. So there are so similar. So if the 1 plus 3 plus 5 up to 67, if this is the sum of first n odd positive integers, then here also there will be n terms. That is, there will be n 22s 22 plus 2 like this n times. Now see that now how do we find n from we know that the last term, that the last odd positive integer is 67. See that if for 1 we know that 1 is the let's say, how do we find? So if let's say this is the, let's try to understand how do we compute the n, that is the how do we compute the n that is inside the first bracket we have the sum of some odd integers, consecutive odd integers. So up to which what is the n, if we consider this is the sum of n first n odd integers, and we know that the last odd integer is 67, how do we find n? So let's see let's see some sum of how we can find n with some examples. Like if the sum is 1, we know n, that is the first n will be 1. If the sum is 1, then we definitely know n is 1. That is 1 means 1, that is it is the sum of first odd positive integers. Now if sum is 1 plus 3, we know n is 2. That is 1 plus 3 is the sum of first two odd positive integers. Now if n is 1 plus 3, if sum is 1 plus 3 plus 5, we know this is the sum of first three odd positive integers. Now, so this n, how this n is related to the sum, you can see that this one, this n, this 1 is nothing but in the sum, the last term plus 1 by 2. This 2 is the last term in the sum, that is 3 plus 1 by 2. Similarly, this 3 is the last term in the sum, that is 5 plus 1 by 2. Okay, so hence if the sum is 1 plus 3 plus 5 like this up to 67, what will be n? What will be n? What will be n? N will be the last term, that is 67 plus 1 by 2. This is 68 by 2. This is 34. So the sum 1 plus 3 plus 5 plus dot 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 plus 67 is the sum of first 34 odd integers. 34 odd integers. Therefore, given sum it will be equal to, in the first bracket, in the expression in the inside the first bracket is the sum of first 34 odd positive integers, and we know its value will be 34 square. Plus we know inside the second bracket we have 34 terms of 22. So it will be 34 multiplied by 22. 22 plus 22 plus 22 up to 34 times. So it will be 34 into 22. So this is the value. This is the value. Now okay, so now what will this value be? How do we quickly calculate this? You can take 34 common, and you have 34 plus 22 using the distributive law of multiplication over addition. This is 34 multiplied by 56. Now we have to compute what is 34 multiplied by 56. That is 24, 20, and we have 20, 15, 17. So this is 1904. So this is 1904. Do we have choice? Yes. So the sum is 1904, and the correct choice is D. So you can take a screenshot of the solution. So while I'm speaking, solving the problem, you should always be taking down notes of any important concepts that I am talking about while solving any problem. Okay, let's do problem number 3. Problem number 3. What is if a and b are whole numbers such that a to the power b uh, a a to the power b is given to be 512, where a is greater than b and b is greater than 1 and less than 4. B is greater than 1 and less than 4. So definitely B has to be either 2 or 3. B has to be either 2 or 3, since A and B both are whole numbers. But they can also be 0. But since it is given B is greater than 1, lies between 1 and 4, so it can only be 2 or 3. A to the power B is given to be 512. Then the value of A to the power 1 by B is. So we have to find what is the value of A to the power 1 by b. We have to find this now. Okay, so we have to clearly express 512 as in some exponential form. Now we know that if you do the factorization, let's now a, okay, now the base a on the left hand side, it is saying that a to the power b is 512 and a is greater than b. So we have to express 512 in an exponential form so that the base will be greater than the power. Now we know that if we divide this is by 4, this will be, let's divide it by 2. So this is 2, 5 and 6, and this is 128, and this is 64, and this is 232, and this is 16, 8. Okay, so we have we can see if I just doing the simple prime factorization, we can see that 512 is 2 to the power. Now it is given that the base will be greater than the power. Now if we consider, if we express as, okay, let's express 512 initially as a power of 2. Then we will figure it out what can a and b such that a is greater than b. Okay, so how many 2's we will have? 1, 2, 3, 4, 1, 2, 3, 4, 5, 6. So it is 2 to the power 6 multiplied by 8, which is 2 to the power 6 multiplied by 2 to the power 3. Okay, so this is 2 to the power 9. 2 to the power 9. Okay, now we cannot, so the base is 2 and the power is 9. We cannot express it, so we have to express it in such a way so that the base has to be greater than the power. In our case, the base 2 is smaller than the power. Okay, so what we can do? Okay, so is it 2 to the power 3? 1, 2, 3, 4, 5, 6. 2 to the power 3. Okay, it is having 2 to the power 9. Now, how can we, now if I okay, so we have to somehow make the base greater than the power. So 2 to the power 9, okay, we can, the power 9, we can write it as 3 into 3. Now this is nothing but we can write it as uh, 2 to the power 3 whole raised to the power 3, because we know that x to the power m into n is equal to x to the power m whole raised to the power n. This is also equal to, we can write it as x to the power n whole raised to the power m. So we were having 2 to the power 9, we were the power, I factorized the power 9 as two factors 3 and 3, so 3 into 3, and then I wrote 2 to the power 3 into 3 as 2 to the power 3 whole raised to the power 3. So this is 8 whole raised to the power 3. 8 whole raised to the power 3, and now we can see that the base 8 is greater than the power b, and also the power b is between 1 and 4. So this implies we can say that a is equal to 8 and b is equal to 3. Okay, now it is asking then the value of, therefore a to the power 1 by b will be equal to, a is 8 to the power 1 by b means 1 by 3. Now even though I have not, now this is particular, actually this is problem is a bit of you will need the concept of cubes and cube roots, which I have not covered, which I have not started in the theoretical playlist, that is CBSE 8 RS Agarwal. So this problem actually is not really appropriate to be solvable as of now, since the cubes and cube roots is not yet done. But if you have done it, then it's good for you. Now what will be this? Now actually you need not actually have know the concepts of cubes or cube roots. It is just the laws of exponents. Now so we have, it is asking to find a to the power 1 by b. A we know is 8 and b is 3, so we have 8 to the power 1 by 3. Now 8 we know it is 2 to the power 3, 2 to the power 3, and this whole is raised to the power 1 by 3. Always know that so far in class 8 regarding the powers exponents, we have already covered exponents. There we have only studied about exponents where the power, that is exponent or index, is a integer. But as a side note, please know that the laws of exponents also works well if the power exponent is a rational number. So this law, that x to the power p whole raised to the power q is equal to x to the power pq, x to the power pq is applicable for any rational number p and q, any rational number p and q. So we can say that this will be equal to 2 to the power 3 multiplied by 1 by 3. This is 2 to the power 1. This is 2. So the answer is 2. So the correct choice is A. The correct choice is A. Okay, let's do problem number 4. For what value of x we can have x minus 2 whole square divided by root 7. So an equation is given that x minus 2 whole square of x minus 2 divided by root 7 is equal to root 28. Now okay, so if we do now we know that for two rational numbers, p by q, if p by q and r by s are two rational numbers, and it is given that p by q is equal to r by s, this will imply we can do cross products. The cross products will be equal. That is, p into s will be equal to q into r. If you do cross product like this, cross product, the cross products are PS and QR, they will be equal. So applying cross products, applying cross products from this equation implies that x minus 2 square will be equal to root 7 into root 8. Now we cannot find, we don't know, we don't know that 7 is not a perfect square, 28 is also not a perfect square. Now please do not immediately try to find the square root of 7 and square root of 28 by long division method. You will get some decimal points. Always try to find before always trying to apply this formula that for any, we know that for any positive numbers x and y, root x multiplied by root y is equal to root of square root of x multiplied by square root of y is equal to square root of x multiplied by y. As soon as you multiply x and y, that number could well be a perfect square. So if I apply this, we can say this is equal to 7 square root of 7 multiplied by 28. Now this is equal to 7, 28 is 7. So we have 7 into 7 into 4. So we can say that this is square root of 7 square and 4 is 2 square. So this is equal to 7 into 2, which is equal to 14. Now you must be familiar with this kind of results regarding the square root. If you have inside a square root some exponential terms, that is powers, that is, let's say x to the power let's say m, x to the power m and y to the power n, then if you want to get rid of the square root, this will be equal to x, all the powers will get divided by 2. So x to the power m by 2 multiplied by y to the power n by 2. Inside square root, if you want to get rid of the, if you want to open the square root, then you will just divide all the powers by 2. So that is the reason inside the square root we were having 7 square multiplied by 2 square. When I opened the square root, it became 7 to the power 2 by 2, that is 1, that is 7 to the power 1 multiplied by 2 to the power 1, which is 7 multiplied by 2 is equal to 14. Okay. Okay, one second. What we are having, x minus 2 whole squared is this. For what value of x we can have square root of no, I think there is 28. There is some problem with the, there is some issue with the problem, I think, because now this actually now, so x minus 2 square whole square, we are getting 14. We are getting 14. But so this will imply x minus 2 will be equal to square root of 14. Square root of 14. This will imply x is equal to square root of 14 plus 2. And 14 is not a perfect square, so we do not really see how come x can be some perfect natural numbers, because all the choices in the given problem are natural numbers like 12, 16, 15 and 18. There is a choice 16. Now this can only happen if x minus 2 whole square, if x minus 2 whole square comes out to be 14 square, then only this can be the x can have a value of 16. So I think there is a little issue with the problem. I might have copied incorrectly the problem. Uh, okay, I'm sorry. I will come back to this problem later on. I think there is a problem. There is an issue with the problem statement. Uh, because as per the given equation, x minus 2 whole square is coming to be 14, and then x minus 2 will be square root of 14, which is not a perfect square. 14 is not a perfect square, so we will not have square root of 14. Will have some decimal numbers, and we will never have a integer as given as in the choices. But if somehow x minus 2 whole square comes to be 14 square, then we can say x minus 2 is equal to 14, and then x will be 16. 14 plus 2, 16. So if it was given x minus 2, if it was given x minus 2, if the equation was this, then we could have, this will imply that x minus 2 will be equal to, as we have already found, this will be equal to 14. So this will imply x is equal to 14 plus 2 equals to 16. But this is not this is not the equation as given in the problem statement. So a question mark. Anyway, so sorry for this problem. I think I have incorrectly copied the problem. It's my mistake. Let's move on to the next question. Question number 5. So this thing happens. It has also happened previously also in the 10 good problem set. While solving a problem, I see that the choices are given incorrectly, or maybe the choices are correct, but the problem statement I have copied incorrectly. So I'm really sorry for that. I apologize for that. These things can also happen in future. Please cooperate with this kind of errors from my side. Okay, problem number 5. Let P be a m-digit number ending with 00. Let P be a m-digit number ending with 00, where m is greater than 2. P is a m-digit number which is ending with 00. So already the number P has 2 zeros at the end. So definitely the total number of digits in the P has to be greater than 0. Okay. If P square is an n-digit number, where n is odd integer, then which of the following is correct? Some relation is given as choices between n and m. We have to find the relation between n and m. Now we know that this seems to be a problem related to the concept that if let the concept is that let a square, if we have that is the square of a is equal to b, that is square root of b is a. Square root of b is a, and let's say a and b are natural numbers, so b is a perfect square and it is a square of a. Okay, so now if let a square equals to b, let b has, that is the perfect square, has n digits. If b has n digits, this will imply that if n is even, if n is even, a will have n by 2 digits. If n is even, n is the number of digits of the perfect square, that is b. If n is even, then a, that is the square root of b, will have n by 2 digits. And if n is odd, a will have n plus 1 by 2 digits. This is a concept that you must know and be familiar with. We have to apply these concepts. Okay. So P is m-digit number ending with 00. So let's say P is something like uh, A, and it is ending with 00. So let's say P is something like A00, where A is some number, A is some natural number having at least one digit. Since M is greater than 2, then A will be at least, M is greater than 2, so has MA, the number of digits in A has to be at least 1. Okay. Now, so this so this will imply the number P has M digits. So this will imply A has already we have two zeros at the end. So A has M minus 2 digits. A has M minus 2 digits, where we are expressing P, the number P, as A00. It is given that the number P is ending with 00. So we are having the two zeros at the end, and before that all the digits to the left hand side of 00, that is the ending to zeros, let that be all those digits, that number be A, and A will definitely have at least one digit. So if the P, the whole number, the entire number P is having M digits, then definitely A will have M minus 2 digits. Okay, now what will be P square? Now this P, we can consider it as A multiplied by 100. A00, a number, any number ending with two zeros, we can if it is of the form A00, we can always write it as A multiplied by 100. Now what will be P square? It is saying that P square is a n digit number, that is the square of P is a n digit number where n is odd integer. Okay, now what is P square in terms of A00? It will be P we have expressed as A00, which is equal to A into 100. So P square will be A into 100 square. This is equal to A square multiplied by 10 square. This is equal to A square multiplied by A multiplied by 100 square will be equal to A square multiplied by 10 to the power 4, because 100 is 10 square. So basically this is 100 square. 100 square. So this is 10 to the power 4. We are having this P square. Now this P square, it is given that is having n digits. So this is again we can write it in the form as A square. Whatever this A square is, it's a number. It will have some it will have some digits, and this number P square will obviously end with 4 zeros, because the number P is ending with 2 zeros. The number P square will end with 4 zeros, as we are having. As you can see, P square is equal to A square multiplied by 10 to the power 4. 10 to the power 4 means 1 and 4 zeros. So P square is of the form A square 0 0 0 0, where A square is some number having some number of digits. Now this will imply, it is given that P square is having n digits. So this will imply that A square will have n minus 4 digits. It is having m minus 4 digits. Okay. Now A square will have n minus 4 digits. Now it is given that n is an odd integer. N is an odd integer. If n is an odd integer, then square. We know that A is how many digits A is having? A is having m minus 2 digits. We have already found that A is having m minus 2 digits. A is having m minus 2 digits, where we have assumed that the number P to be we have expressed the number p as a00, because p is ending with two zeros. The last two digits will be 0, and all the digits before the last two digits we have considered as a. So p is a00, which is actually a multiplied by 100. So from that we got p square, which is a square, and then a square multiplied by 10 to the power 4, which is basically the p square will look like, it will have 10 zeros, it will end with 4 zeros, and before that, whatever before the p square is ending with 4 zeros, and before the 4 zeros, whatever the number is that we are considering as a square, it has to be a square. Now it is given that the number p square is having n digits, so definitely this a square will have n minus 4 digits, because we have to subtract the 4 zeros, n minus 4 digits. Okay. Now n is odd, is given that n is odd. If n is odd, this will imply if we subtract an even number from an odd integer, it becomes an odd integer. So this will imply n minus 4 is odd. If n is odd, if you subtract an even number from an even integer from an odd integer, the result is also an odd integer. You can see that, let's say n is odd. Let's say if you subtract n is odd, let's say n is 7. If you subtract any even number, it is 5. 7 minus 4 is 3. So if you subtract an even integer from a larger odd integer, the result is also an odd integer. So this implies n minus 4 is odd. And what is n minus 4? N minus 4 is the number of digits in a square. So we are having that a has m minus 2 digits, and we are having a square is having n minus 4 digits. So consider these now results. A has m minus 2 digits, a square has n minus 4 digits, also n minus 4 is odd. So this will imply that, based on the fact that a square has n minus 4 digits, which is odd, n minus 4 is odd, we can say that a, based on these two facts, we can say that if a square is having n minus 4 digits and n minus 4 is odd, we have already proved that n minus 4 is odd, because n is given to be odd, so n minus 4 will be odd. So we can say that the square root of a, that is a square root of a square, that is a, will have n minus 4 plus 1 by 2 digits. Since we know that if a square number, if a perfect square has n digits, and if that n is odd, then its square root will have n plus 1 by 2 digits. So in this problem, we are having a square, which is a perfect square, is having n minus 4 digits, and n minus 4 is odd, then the square root of a square, which is a, will have n minus 4 plus 1 by 2 digits. But as per our assumption, we have already have the result that a has m minus 2 digits. So this will imply m minus 2 is equal to n minus 4 plus 1 by 2. This will imply m minus 2 is equal to m minus 3 by 2. If you do cross products and equate the cross products, this will imply 2 into m minus 2 is equal to n minus 3. This will imply twice m minus 4 is equal to n minus 3, and this will imply twice m. If I bring the n to the left hand side and minus 4 to the right hand side, I get 4 minus 3 equals to 1. So this implies twice m minus n is equal to 1. So this is the relation we are getting, and the correct choice is C. C is the correct choice. So this was a conceptual problem based on the fact that if a square number, if a perfect square has n digits, and if n is odd, then its square root will have n plus 1 by 2 digits, and if n is even, then the square root will have n by 2 digits. This problem is entirely based on this concept. Okay, so you can take a screenshot of the solution. Okay, let's solve question number 6. Question number 6. Okay, so what is given? Square root of 3 to the power n is equal to 729. Then the value of 4n square. We have to find the value of 4n square minus 8. We have to find this value. Okay. Now on the left hand side we see a square root and there is a 3 to the power n, and on the right hand side we see 729. Okay. So now 729, we know this is, let's factorize it so that we get we will obviously get a power of 3. Now this is 9 multiplied by 81. So this is 9 multiplied by 9 square. This is equal to 9 cube. Okay. So we know that 729 is 9 cube. Now on the left hand side we have square root. To get rid of square root, we can square both sides. Squaring both sides. My machine is so slow, I can't write properly. Squaring both sides. Squaring both sides, we get square root of, I'm just squaring both sides. I can always do that. I get this. Okay. Now, what will be the left hand side? What is the square of a square root of a number? Square root of x. If you take the square of this, the square of the square root of x is x itself. Is x itself. Also, you must know this, that the square root of x square is also x. So the left hand side will be 3 to the power n, 3 to the power n, and the right hand side will be 9 to the power 3. We have 9 to the power 3 and then its whole square. So this is 9 to the power 3 multiplied by 2. So this is 9 to the power 6. Okay. Now on the left hand side we have the base. So this is we have to solve n. We have on the left hand side the base is 3, and we on the right hand side the base is 9. We have to somehow convert the right hand side number as base 3. We can always do that. We know that 9 is nothing but 3 square, and we are having whole to the power 6. So this is equal to 3 to the power 2 multiplied by 6. This is equal to 3 to the power 12. So now we see that 3 to the power n is equal to 3 to the power 12. Both the left hand side and the right hand side are exponential term. The bases are equal, so the powers must be equal. So we are having, if we equate the power, we get n equals to 12. N is equal to, we are getting 12. Now we have to find the value of 4n square. 4n square minus 8. This is equal to 4 multiplied by 12 square minus 8. Now, if you take you can do now you can the 12 square is 144. You can multiply 144 with 4 and then subtract 8, but I would like to take 4 common from here, and this becomes 12 square minus 2. Now, anyway, I mean, this is a simple simplification of taking a squaring a number, multiplication and subtraction. So what is this now? 4 multiplied by 12 square is 144 minus 2. So this is 4 multiplied by 142. This is 8, 16 and 568. So 568 is the value of 4n square minus 8. So the correct choice is D. Correct choice is D. Okay. Okay, let's do problem number 7. It is saying that if x is the least number that must be added to a number is given 4515600 to make it a perfect square, then the value of square root of the same number plus x is. If x is the least number that must be added to 4515600 to make it a perfect square, then the value of square root of that number plus x. Now see that it is saying that x is the least number. We have solved this kind of problem where we are asked to find the least number that must be added to a given number to make it a perfect square. What do? We find the square root using the long division method. We get a remainder, and in finding the least number to be added to a given number to make it a perfect square, what do? Let's say the given number is n, and we do long division. Let's say and the remainder is let's say r. The final remainder is r, and the final quotient is q. Let's say we are doing long division to find the square root of n, number n, and we are getting finally the remainder. This is the remainder, final remainder. This is the final remainder, and this is the quotient. This is the quotient. So what does this mean? This will imply that the number n is nothing but q square plus r. The number n is nothing but q square plus r. That is why you are getting a remainder r. You are getting a remainder r when you are finding the square root of n. And okay, also we know that from this we know that q square, the number n is definitely greater than q square, and it will be less than q plus 1 square. So the least number that must be added to n to make it a perfect square is q plus 1 whole square minus n. So that number is given to be x. It is given that x is the least number that must be added to 45160 to make it a perfect square. Then the value of. Now, in general, when we are asked to find the least number or to be added to a number n so that it becomes a perfect square, we do a long division to find the square root. Let the final quotient becomes q, and the final remainder, we will get a remainder r, and we will get a quotient q. From there we can say that the given number n is obviously greater than q square. It is lie between q square and q plus 1 whole square. So this implies that least number to be added to least number to be added to n to make it a perfect square, a perfect square is equal to q plus 1, because uh, the number the number that must be added to n, after adding the least number that must be added to n to make it a perfect square, that perfect square will be the next number larger than n, which is a perfect square, which obviously has to be q plus 1 square. So that perfect square is q plus 1 square. So what number need to be added to n? That will be obviously q plus 1 square minus n. Now in this problem, q plus 1 square minus n is given to be as x. In this problem, this is given to be x, and n is equal to 4 5 1 5 6 0 0. Now also notice that if I add, what will be, so the least number to be added to n to make it a perfect square is q plus 1 whole square minus n. Now this implies, if we consider that this least number to be added, which is q plus 1 whole square minus n, that is x, as per in the given problem, that is x, then we can say that the square root of n plus x has to be equal to q plus 1, has to be q plus 1, because when we add the least number to be added to n to make it a perfect square is q plus 1 whole square minus n. If that number q plus 1 whole square minus n, if we consider that to be x, then definitely n plus x is equal to actually before this we must write that n plus x is equal to q plus 1 whole square. Now we can say that square root of n plus x is equal to q plus 1. So in the problem, what we have to find, q, just q. And what is q? Q is nothing but the quotient of finding the square root of the n using the long division method. So in the problem, we have to find the square root of 4 5. We have to find the square root of 4 given number 600 using the long division method, and whatever the quotient will be, that plus 1 will be the answer. Now let's do find the square root of 4515, the given number, using the long division method. We mark the periods, this and 4. So obviously it will start with 2. We have 2 2. We have 4 0. We bring down the next period, that is 51. 51 becomes the dividend. 51 has to be appended with the remainder. Remainder is 0. So 51 is the new dividend. The new partial divisor will be the quotient, current quotient, multiplied by 2, that is 2 into 2, 4. Now we have to find a digit x after 4, such that the 2-digit number 4x multiplied by x will be less than or equal to 51, and this x has to be maximum, that is maximum digit x, such that the 2-digit number 4x multiplied by x is less than or equals to 51. So this obviously implies that x has to be equal to 1. So we put x as 1, we append 1 to the quotient, and this becomes 41. 41 into 1 is 41. We subtract 41 from 51. The remainder is 10. We bring down the next period, append it with the remainder. So the new dividend becomes 1056. Now the new partial divisor will be whatever the current quotient is multiplied by 2. So 21 multiplied by 2 is 42. Now again we have to find x, the maximum digit x, such that the 3-digit number 42x multiplied by x will be less than or equal to 1056. So this implies, can x be 4? No. Can x be 3? No. I think x will be equal to 2, because let's see, 4, 2, 2 multiplied by 2 is 4, 4, 8. It cannot be 3. It cannot be 3 because it will exceed 1056. So x will be 2. X will be 2. You append 2 with the quotient, and then 4 to 2 multiplied by 2 is 844. You subtract 844 from the dividend, you get the remainder as 2 1 112, and then you bring the last period, that is 00, append it with the remainder 112, and you get 11200 as the new dividend. Now the next partial divisor will be whatever the quotient is multiplied by 2. So 212 multiplied by 2 is 424. Now again you have to find the maximum digit x such that the 4-digit number 424x multiplied by x will be less than equal to 11200. So this will imply, what will x be? Can x be 3? No. Can x be 2? X cannot be 3. So x has to be, let's say, 2. We have to find it out. So 2 multiplied by 2 is 4, 8, 4, 8. Okay, so x will be 2. X will be 2. We append 2 to the current quotient, and 4242 multiplied by 2 is 84 and 84. We subtract that from the current dividend. The remainder is 6, 1, 7 and 2. So anyway, the purpose was to find the quotient, because we need the quotient. The answer will be this quotient plus 1. But we are not having, if this is the quotient, 2122, 2122 plus 1 will be 2123. 2123. We are doing something wrong. Maybe I have done something wrong in the long division method. I have to check. I am very prone to making calculation mistakes. Now we are having 2122. What are the choices? 2125, 2125. The closest, 2115. Okay. Okay. I have to check it once again. The long division method right from the start. So periods are 00, 56, 51 and 4. Okay. We are starting with 2. It is 2, 2, 4. The remainder is 0. We bring down 51. Dividend is 51. And the partial divisor will be 4. So it will be 41, 1. 41, 1. So 41 subtracting from 51 gives 10. 10. We bring down 56. And then the partial divisor will be 21 multiplied by 2, that is 42. 42. And then we are having 2. The digit we are adding with the divisor is 2. It cannot be 3. Okay, 2. So 2. We are having 844. Okay. So 844 when subtracted from 1056 is, this is 2 and this is 5 and this is wrong. Okay. So this will be 2. This will be 2. This will be 2. So this will be wrong. This will be wrong. And this all will be wrong. Okay, so I have up to this. Okay, now we have to see that we have to we have to find the largest digit x such that 424x multiplied by x will be less than equal to 21200. 21200. So this implies x will be it can't be 5. Can it be 5? Can it be 5? Let's see. Can it be 5? 4, 2, 4, 5 multiplied by 5, how much is it? 25, 20, 22, and then 10, 12, and then 20, 21. No, it is exceeding. So definitely x will be 4. X will be 4. And what is 4 to 4 4 multiplied by 4? This is 16, 17, 9 and 16. So x will be 4. X will be 4. 4 will be appended here to the question, and this will be 16976. So you must should not make any calculation mistake in solving a problem. That is very super important. Now at this stage, since all the periods are exhausted, it doesn't really matter with whatever remainder it will come, because we just need the question, we just need this. So the answer has to be 2124 plus 1, that is 2125, because we have already discussed that square root of n plus x has to be a q plus 1, where if the given number is n, and if x is the least number to be added to n to make it a perfect square, where in the long division method of finding the square root of n, the quotient is q, we will always have square root of n plus x is equal to q plus 1. Okay, so the choice is correct choice is D. Correct choice is D. Okay, let's do problem number 8. We have to evaluate, and we are given a very long expression involving nested square root, that is square root inside square root, and we are also having a mixed fraction. Okay, instead of writing the entire expression again and again, I will solve. Let's solve part by part. Let's see what is this. Let's try to figure out what is this. 4. This is a mixed fraction, 41 by 100. Now this will be equal to, if we convert the mixed fraction to an improper fraction, this will be 100 multiplied by 4 plus 41 divided by, we are having 100. This is equal to square root of 400 plus 41, that is 441 is a perfect square, I know, but what is the its square root, I do not know. But 441 is a perfect square because we have solved problems from the exercise of textbook author R.S. Agarwal, and we have seen that 441 will be is a perfect square. Now, what can its square root will be? It is ending with the digit 1. If a perfect square is ending with the digit 1, its square root can end with the digit 1 or 9. 1 and 9. Okay. So, can it be 21? Can it be 21? 21 multiplied by 21. This is 21 and this is 42. Okay. So, it is 21. So, this is now this is square root of 441 by 100. We see that this is the square root of a fraction, and we know that we see that the fraction, in the fraction, both the numerator and the denominator is 100 and the numerator is 441. They are both perfect numbers, perfect squares. They are both perfect square numbers. So we will apply the formula that square root of a fraction x by y is equal to square root of x divided by square root of y. So this will be square root of 441 divided by square root of 100. So this is equal to 21 by 10. This is equal to 2.1. Okay, that was that. Now let's see what is. Let's see. Let A be the term. Now, okay. Before that, let's see what is. Let's try to find out the square root inside. In the first term, we have nested square roots. Let's try to simplify some inner square roots. So, what is square root? What I am doing. So, what is square root of 1024? Square root of 1024. This is 1024. Now 1024. Okay. So I have to do even though this is a very standard numbers, you should always be knowing uh, uh, the square root of 1024. So anyway, so 1024, if I do factorization, if I straight away divide by 4, I have 8, 5 and 6. So this is 6 and 4. Okay, 6 and 4. So this okay, so this is square root of we can see 4 square multiplied by 64. So this is equal to 4 square 4 square multiplied by 64 is 4 to the power 4. 64 is 4 to the power 4. No, sorry, 64 is uh, 64 is, sorry, see what I am doing, 64 is 8 square. Okay, 8 square. So this, so the square root of 4 square multiplied by 8 square is nothing but 4 into 8. This is 32. Okay, 32. Now what is square root of, then square root of 112 plus square root of 112 plus square root of 1024 will be equal to square root of 112 plus 32. This will be equal to square root of 112 plus 32 is 144, and we know that this is equal to 12. Okay, now what will be square root of 208 minus, I am solving this problem in a really peculiar manner, but I hope you are getting the idea. We have already found this thing, square root of 112 plus square root of 1024. So this will be equal to square root of 208 minus 12. This is equal to square root of, how much is 208 minus 12? This is 6, 8, and this is 8, and this is 186. 186, 186, 8, sorry, this will be 196, sorry, 196. 196, and I know this is 14, because 14 square is 196. 14 square is 196, so square root of 196 is 14. So we have this. So now we have the entire the entire expression, whatever is given, is turns out to be square root of 7.16 plus 14. And we have minus 2.1. The square root of the mixed fraction was coming out to be 21 by 100, that is 2.1. 2.1. Okay. Now in the first expression we are having some decimal number. So 7.16 plus 14 is how much is this? 21.16. Now I think okay, so this is minus 2.1. Now this is equal to 21.16 is 2116 divided by 100. Now somehow I think that the 2116 will be a perfect square number. Let's see if it is a perfect square number or not. 2116. Will it divide by 4? I think so. Let's see. 5 or 20. Yes, 9. What about 529? I know 529 is a perfect square, but what is its square root? 30. I hope I did it right. 4, 36, 8, 11. Okay. Now, will it divide by 9? 529 or 7? 40. No. 7, 6, 7, 49, 39. No, 9. 9, 9, 9, 6, 54, 9, 5, 45, 7, no, 17. 17. What is the square? 529. It is a perfect square number. What is its 20? Let's try 27. Let's see. Is the square of 27? Is 27 square is 529? Let me see. 27 multiplied by 27 is 49. 14, 18, and I have 14 before 5. No. It is 729. 17, 17, 17. No, it will not be 17. 17. Okay, one option can be it can be the square root of 529 can end with a digit either 7 or 3. 7 or 3. So what about 23? 23 multiplied by 23. This is 9. This is 6, and this is 6, and this is 4. Yes, 9, 12, 5. Okay. So we can see that 216. We can see that 2116 is equal to 4 multiplied by 529, which is equal to 4 multiplied by 23 square. We got this. So this thing now becomes square root of now we can see that 2116 is definitely a perfect square because 2116 is 4 multiplied by 23 square, which is a perfect square because 4 is 2 square. So we can say that this fraction, the square root of 2116 by 100, we know that it's a fraction. Both the numerator, that is 2116, is a perfect square, and the denominator 100 is also perfect square. So we can write it as square root of 2116 divided by square root of 100, and we have minus 2.1. This is equal to 2116 is 4 multiplied by 23 square, and 4 is 2 square. We have 2 square multiplied by 23 square, and of course we know 100 is 10 square, and we have minus 2.1. So this implies the square root of 2 square multiplied by 23 square is 2 into 23, and the square root of 100 is definitely 10 minus 2.1. So this is equal to 4.46 46 by 10 minus 2.1. This is 4.6 minus 2.1. This is 2.5. So 2.5 is the answer of this, or this is the simplified value of the given expression. So the correct choice is B. Correct choice is B. Okay. Okay, let's do. Can you see the problems properly? Okay, let's do problem number 9. The product of two numbers is 2820, and their quotient is 47 by 15. The larger number is. The product of two numbers is 2820, and their quotient is. If the numbers be x and y, let's say one has to be greater than the another one. Let's say x is greater than y. Let's say you can also consider y is greater than x. It will not matter. Eventually, you will get the correct answer. Okay, so we are considering the two numbers to be x and y, and I'm considering that x is greater than y. So what do we have? We have xy is given. The product of the two numbers given is 2820. Okay, what else we are having? And the quotient is 47 by 15. So since we have assumed x is greater than y, and 47 by 15 is a mixed fraction, it is an improper fraction that is greater than 1, because the numerator 47 is greater than the denominator 15. So this 47 by 15 has to be x by y because we have considered x is greater than y. So we are having x by y as 47 by 15. And what is asking? The larger number is. So we have to find the larger number is, that is x. How do we find x? From these two equations, this equation and this equation. Okay, so if you multiply, let's say if this equation is 1, and this equation is 2, multiplying 1 and 2, we get the left hand side becomes xy multiplied by x by y, and the right hand side becomes 2820 multiplied by 47 by 15. Okay, the left hand side y gets cancelled and we get x square is equal to 2820 multiplied by 47 by 15. We have to do some cancellation. So eventually we have to find x. That is, we have to find the square root of the right hand side. Okay. Now 47 is not a perfect square. We have to see. We have to cancel, do cancellation and see what simplified value it comes to. So 5, 3, 5, 5, 25, 6 and 4. Okay. Will it divide further? 3, let's see, 1, 8 and 8. Okay. So this is x square is 188 multiplied by 47. Multiplied by 47. 188 multiplied by 47. How do we find x? We have to find the square root of 188, 47. Now will 47 divide 188? 47 4. 28, 16. Okay. So 188 is nothing but 47 multiplied by 4, and we have 47. Okay. So this is 4 multiplied by 47 square, or this is 2 square multiplied by 47 square. So this implies x will be equal to square root of 2 square multiplied by 7 square. This is 2 multiplied by 7, that is 14. We have 14. The larger number is. What is wrong? We are having 14. We are having 14 and x is the larger number. Oh, sorry, this is not 7 square. What I am doing. 2 square into 47 square. So we will have 2 square into 47 square, and this will be 2 into 47. This is equal to 94. So the larger number x is 94, and the correct choice is D. Correct choice is D. Okay. Let's do the last problem. Question number 10. What is given? Let P is given a square root of P is given to be square root of 0.2304, and Q is given as square root of 0.1764, and it is given that P plus Q divided by P minus Q is equal to 3 to the power x multiplied by 4 to the power y multiplied by 5 to the power z, then the value of x plus y plus z. Okay. P is a square root of 0.2304. and q is square root of 0.1764. And we are given this equation p plus q divided by p minus q. Now first we have to see whether this numbers inside the square root, uh, the decimal places is 4, so we can convert that as a fraction, and we will have in the denominator 10 to the power 4, whose square root is 10 square. But we have to check whether 2304 and 1764 is a perfect square or not. If it is, then life will be easy. How do we find whether 2304 is a perfect square or not? It is 2304, 4, it is ending with 4. So the square root, if it is a perfect square, then the square root must end with 8 or 2. 8 or 2. If you do a little bit of guessing, 2304, if its square root ends with 2, what can that square root be? No, 4, 42. Can it be 42? I'm doing a very, very wild guess. 42 multiplied by 42 is 4, 8, and 8 and 16. No. It is better. Now, another way is that if you quickly check, do prime factorization of 2304 to see whether it's a perfect square number or not. Will it divide by 4? Yes, it will divide by 4. So 5 and 7 and 6. Okay. So it should again divide by 4. 1, 4 and 4. Okay. So it is a perfect square. We can see. So 2304 is equal to 4 multiplied by 4 multiplied by 144, which is equal to 4 square multiplied by 12 square. Okay, let's see what is 1764, whether it's a perfect square number or not. Will it divide by 4? Yes, it will. 4, 4, 16, 4, 1. Okay, it will. So 441 is a perfect square. We have already seen in some previous problem where was a problem 441, 441, 441. The square root is 21. Okay, 21 square is 441. So 1764 is equal to 4 multiplied by 441 we know as 21 square. So this is equal to 2 square. 4 is 2 square multiplied by 21 square. So both the numbers, these two numbers, 2304 and 1764 is a perfect square. That is, we can write this as 4 multiplied by 2 whole square, and this we can write as 2 multiplied by 21 whole square. So this will imply what will be p is equal to square root of 0.2304. If I convert the decimal to a fraction, it is 2304 divided by 10 to the power 4, because the decimal places is 4. Now this we can write it as square root of 2304 divided by square root of 10 to the power 4. And square root of 2304 will be, obviously 2304 is 4 multiplied by 2 whole 4 multiplied by 12 whole square. So square root of 2304 will be 4 multiplied by 12, and square root of 10 to the power 4 is 10 square. So this is equal to 48 by 100. This is equal to 0.48. So P is 0.48. Similarly, what will be Q? Q will be square root of 0.1764. This is equal to square root of 1764 divided by 10 to the power 4. This is equal to square root of 764 uh, divided by square root of 10 to the power 4. Now square root of 1764 will be 2 multiplied by 21, because 1764 is equal to 2 multiplied by 21 whole square, and square root of 10 to the power 4 is 10 square. So this is equal to 42 by 100. This is equal to 0.42. So we have P as 0.48 and Q as 0.42. Now let's see what is P plus Q divided by P minus Q. This is equal to P is 0.48 minus 0.42 divided by, plus 0.48 minus 0.42. This is equal to, the numerator becomes 0.9 divided by, and the denominator becomes 0.06. 0.06. P is 0.48, Q is 0.42. So P plus Q is 0.48 plus 0.42. P minus Q is 0.48 minus 0.42. So the numerator becomes 0.48 plus 0.42, which is 0.9, and the denominator becomes 0.48 minus 0.42, which is okay. So this becomes 9 by 10 divided by 6 by 100. So this is equal to 9 by 10 multiplied by 100 by 6. This is equal to 10 3 2 3 3 and 5. So 3 into 5 is 15. 15. Okay, so P plus Q divided by P minus Q is 15, and it is given in the form of some exponential product of some exponential term. Now 15, how can we write it? 15 is nothing but 3 into 5. So this implies 3 into 5 is equal to, given as 3 to the power x, 4 to the power y, and 5 to the power z. So this implies definitely x will be 1. If we compare the power of 3 and 5 on the left hand side and the right hand side, x will be equal to 1, z will be equal to 1, and y will be equal to 0, because 4 to the power 0 is 1. 4 to the power 0 is 1. So this implies x plus y plus z is equal to 1 plus 1 plus 0. This is 2. This is 2. So the correct choice is C. The correct choice is C. Okay. There was one problem which I marked as question mark. What was that problem? Which problem was that? This one, 4. Okay. So question number 4, let's give it a second try. It is given that for what value of x we can have x minus 2 whole square divided by root 7 is equal to root 28. So x minus 2 whole square divided by root 7 is equal to 28. Applying cross products, we get x minus 2 whole square equal to root 7 multiplied by root 28, which is equal to square root of 7 multiplied by 28. 7 multiplied by 28 is equal to 7 square into 2 square. So its square root becomes 7 into 2, that is 14. So we are having x minus 2 whole square is equal to 14. So x minus 2 will be square root of 14. This is correct. But 14 is not a perfect square number. But the choices are given as natural numbers. And there is a choice 16. The closest choice can be choice B 16 if we somehow get x minus 2 is equal to 14. Possibly, okay, so if this problem was x minus 2 divided by root 7 is equal to root 28, then we will get x as 16. In that case, we will get x as 16, and the choice will be 15. Choice will be B. But as per the given problem, the given equation, we are having x as square root 14 plus 2, and square root 14 it will be a number in decimal number, because 14 is not a perfect square number. So this problem was a little controversial problem. I'm sorry, I might have done something wrong in writing the problem, the equation, or the choices. I think the choices are fine. I might have done something wrong in the writing the equation. I'm sorry for this. So anyway, this brings to an end in solving 10 good problems, set 1 on the chapter of squares and square roots. This chapter, squares and square roots, I have just completed from the playlist CBSE Maths 8 RS Agarwal. If you have not watched those videos, you are requested to watch the videos from the playlist CBSE 8 RS Agarwal, where I have completed up to the chapter squares and square roots. I hope this video was beneficial. This set of problems will give you a good evaluation of your understanding of the concepts of squares and square roots. And this kind of 10 problems will come every now and then, as this is an unlimited series of 10 good problems. I will keep on preparing 10 good problems from each chapter as and when they are complete in the playlist. As and when they are complete and covered in the playlist CBSE 8 RS Agarwal, I will keep on making this kind of 10 good problems for each chapter. So this was set 1 of 10 good problems on the chapter squares and square roots. The next set will be 2. So if this video was beneficial, then please like it, share it with your friends, and once again, please support me by subscribing to my channel, and do not forget to press the bell icon so that you will be notified by my future videos. Stay tuned for the next set, set number 2 of 10 good problems on this chapter, and also look out for my videos on the playlist CBSE 8 RS Agarwal, where I discuss about the theoretical parts of the chapters and solve all the exercise problems from the textbook of author RS Agarwal. And also in that playlist, I prepare and solve 2 sample test paper after one chapter is complete. So thanks for watching, and until the next video, take care and bye.